Good morning. Thank you everyone for turning up to our talk at 9:30 in the morning on Thursday. My name is Matt Sullivan. I am on the Flutter team at Google.
And my name's Andrew Brogdon. I am also on the Flutter team at Google. And so we're here today to talk about an app that we built in partnership with Devoxx. It's the VoxxedDays app, and it looks like this. And so it displays information about upcoming VoxxedDays events, the schedules, details about where it is, things like that, the speaker lists, and so on. And we recently built it in Flutter. It's currently in an open beta. And we're going to tell you about how we built it and some things that we learned along the way.
Okay, but before we do that, I would love to find out, everyone put their hands up. Everyone, hands up, please. Everyone, this is a stick up. Thank you very much. If you have not heard of Flutter before, drop your hands. Okay, if you have not actually written any Flutter code, drop your hands. Wow, okay. If the very few people who are left, if you have not written an actual running app in Flutter, drop your hands. Way, we have 3 people who have actually written Flutter apps. Thank you very much. So for those of you who are not too familiar with Flutter, I'm going to spend a few minutes just covering the basics. What we really want to do in this talk is get down to showing you some real code. So we are going to actually, well, Andrew's mostly going to build some code live on stage, but bear with us while we get through some foundational stuff. So what is Flutter? In more like 10 minutes or less, but I could try to do it in 5. Flutter is an SDK for building apps on iOS and Android. So for building apps like you see on the screen here. There's 4 apps. 3 of them are in production, built by third parties around the world. And the 4th, that house, is a demonstration app that we worked with 2 Dimensions to build just to show the fluidity of the UI. And the thing to take away here is these don't really look like out-of-the-app material apps. They don't really look like out-of-the-box iOS apps. And that's because one of the core tenets of Flutter is the ability to create not only fluid UIs, but to create very customized UIs. So what is the pillars, the TLDR, the quick summary of Flutter? It's about building customized fluid UI. We use a reactive pattern to be able to construct apps. So if you're familiar with React.js, or you're familiar with React Native, or familiar with things like RxJava or even streams, this pattern feels like what I think is a natural fit for this problem. We natively compile down to iOS and Android. There's no jitting, there's no interpreting. It's a little more nuanced than that, and I'll talk about it in a minute, but suffice to say, we're basically running an ARM machine code for all of the Flutter code that you write when you go to release mode on the device. And we could give you the greatest SDK on the planet to let you build mobile apps, but if we don't give you the tools, you're not going to have the world's greatest experience. So we have put an emphasis on making sure that our tooling is good so that your experience is good when building Flutter apps, because Flutter apps, building them is meant to be a joy. And personally, I actually really enjoy building mobile apps using Flutter. Why do we say custom fluid UI? Well, we're a little different to how a number of other cross-platform technologies work in terms of how we render UI. We have our own renderer inside Flutter. So we use Skia, which is an open source renderer used across a bunch of open source projects. And we use that to draw everything ourselves. We don't use native UI components in the platform. When you see an app bar running on Android and Flutter, that is not being rendered by the Android SDK or the support libraries. When you see a nice button or text field in iOS, that's not being drawn by the iOS SDK. That's being drawn by representations that Flutter draws itself. And so there are no UI components used. So we're actually more like like Unity, where we take a blank canvas and we go, let's actually render the complete UI ourselves. And this gives us some challenges in terms of maintaining our implementations of the UI components, which we aim to do on release of every upgrade of Android and every next release of iOS. But what it does give us is it gives us the ability to optimize the rendering based on the widgets you're using on each platform and give you a good representation across both platforms. Now, we don't simply go, let's render this on an open canvas and ignore what platform you're running on. We will take into account UX. If you're on iOS, you will get the scrolly bounce. If you're on Android, you'll get the inkwell effect. So we will take that into account. You're welcome to override it, but out of the box, you don't need to worry about it. And we also have an engine embedder. So we have an engine implementation for iOS and Android, but you can create an embedder for other platforms. We have an unofficial one for macOS. There are people out there who are building embedders for Windows. So we are focusing currently on mobile, but in the future, there's nothing preventing Flutter from running across anything that can give us effectively a canvas on which to render. The entire UI stack is built in Dart. I'll be very curious later on for those people who haven't seen Dart and for a largely Java audience, what you think of the language, because it's C-based. It should be very natural for you to read. When I came to Flutter about a year ago, I looked at the code and I went, well, I can read this in the space of a couple of days. I was proficiently coding in it. There's not a big context switch here, but you'll see that when we play around with it ourselves. The important thing here, though, is that because it's implemented in Dart and because all the source code is available to you before compilation, you can actually read the full source code for how we build every single widget on the platform. And you can dive into any level and you can start to customize. So you can go, I want to use a material design app bar, I want to use an iOS text field, and you can do that because we have material and what we call Cupertino widgets, which are UI components for those. But you can drop down to the lower level widget layer. You can actually drop down to the rendering layer or further down and play around with how our animation framework works down to the foundation. So you can control pixel painting at any level, which is why you can create a UI which is heavily customized without having to jump through a lot of hoops, worrying about mapping back to native UI components. Our UI layout is through code. We do not have a markup language. We don't use XML. We don't use HTML or anything like that. We do it in code. And while that might be jarring for people, it was jarring for me initially, having come from doing a bunch of Android stuff for a couple of years. It is actually a very elegant pattern when you see how the reactive framework works and how the Dart language itself supports that. So suspend your disbelief because you're actually going to see it in action very shortly. Let's talk briefly about the reactive pattern. If there's one thing you remember throughout the coding exercise, it's this. Everything in Flutter is a widget. And I mean everything. I don't just mean the UI components are widgets. I mean everything is pretty much a widget. And I'll show you what we mean in a second. We have two main types of widgets, stateless, which is a widget which may have data, but it's immutable. And we have stateful widgets, where you can, they have the concept of state, and will have the concept of being able to rebuild themselves, and the widgets that depend on it when that state changes. And when I started coding Flutter, I had this tendency of taking a stateless widget, and I knew it wasn't going to change, even though up above it might get re-rendered, and I would do a lot of things to try to keep a reference to it. That's not the Flutter way. That's not following good practices when you're programming in this pattern. Rebuilding widgets in Flutter is cheap. And sure, there's a small cost to it, but you should not be afraid to let your stateless widgets die when data changes and have them rebuilt, because the platform is optimized to do that. So on the right, there is the most boring app you could possibly imagine, designed by me, because I can't do design. And let's take a look at how this is represented in Flutter. So there's a button. So how are we going to instantiate a button? Well, we have a raised_button class. So there is how Dart would instantiate the raised_button class. That's great. I can instantiate a button. But this button has text. So what am I going to do? Well, we have a text widget. So our raised button can take a child, which can be any widget, and we'll give it text. But that could also be an icon. Or it could be some sort of custom rendered drawn thing. Or it could be something animated inside the button itself. So again, everything is a widget. We just happen to put text here. Now this button is centered in this main area. How do we do that? Well, our layout is also defined by widgets. So we have a centered widget, which takes the child, which is the raised button, which takes the child, which is the text. And you can see us building up a tree here. But the important thing here is that centered works on any widget. So you have great flexibility as to compose these together. Let's finish up, because we still have an app bar, which also has text. So we have an app bar widget, we have a text widget, and then Flutter gives you this handy scaffold widget, and that just gives typical layout of an app. So where does the app bar live? Where does a floating action button live? Where does a drawer or a bottom nav bar live? It will take those pieces and it will render them in the appropriate places in the appropriate fashion for the platform it's running on. So here we have a widget tree of a very, very simple app, and the code looks like this. Here's the code to render that main body, center, raise button, text, and then that also has an onPressed, which takes a closure, which we're currently not doing anything with at the moment. Then we have the app bar section. Again, there we go. We have app bar and we have text wrapped in a scaffold, and this whole thing is wrapped in a custom widget I created called My Button Page, which I can now use as the root of my application. I could use it as a page in my application. I could actually put it into a subsection in my application, which would be weird because it has an app bar, but I could do that because it is just a widget. Moving swiftly on, we have native compilation. As I said, in release mode, everything compiles down to ARM machine code. But it doesn't end there, and one of the reasons why we use Dart is Dart has a flexible compiler toolchain, and it also has a VM. So when you run in debug mode, we actually push the VM alongside the app. And whenever you modify your Dart code, we can push those changes over in near real time. So while you're actually while you're developing, you can make a change to your Dart code, it can get pushed over to the device, and you will see that rendered almost instantaneously. So it gives a really good developer experience. But when you go to release, we strip out the VM and a bunch of other pieces, and we compile it down to be as lean and mean and as fast as we can. And currently, our base infrastructure for release mode in Android is about 4.78 megabytes, because we still have like the garbage collector for Dart, and we still have some foundational stuff for creating and destroying objects. But that number was over 6 meg 2 months ago. So we're making great strides in pushing it further and further down. Finally, you're going to see Andrew playing with IntelliJ very shortly. We support IntelliJ, Android Studio, and Visual Studio Code. We have built plugins for all of these. If you like to use Vim, you can totally do that. I do it on occasion because I have full CLI support, and I can run everything from the command line, and I can script it up as I like. Hot reload is our ability to push code over when you're developing. And we have a full-blown package manager as well, so that when you use third-party packages, and there's a great set of resources out there for both native Dart and for Flutter as well that you can utilize. And we do all the dependency resolution and everything else for you, so you can use that. And finally, we have the ability to not only use just Dart code, but you can call down to native Objective-C, Swift, Kotlin, and Java code as well. If you want to reuse something you've already built, or you're doing something particularly weird on that platform, you always have the flexibility to move between them. So there is Flutter in a lot more than 5 minutes, but kind of under 10. So what exactly did we build?
I can show everybody.
Sure.
I apologize in advance for my slight cough. I imported a cold from the States earlier this week. So yes, what did we build, and how does it work? So this is the VoxxedDays app that is, again, currently in an open beta. It's an open source Flutter app. All of the code for this app is on GitHub right now, and you can look at it. And of course, all the Flutter code is also open source, so you can look at that on GitHub as well. It displays information and schedules for upcoming VoxxedDays events. It offers local notifications for favorites, so you can sort of favorite a talk and get a notification 10 minutes before it's going to start. It uses a customized material design, and it takes advantage of the VoxxedDays REST API to get its data. So there's several REST endpoints that the Devoxx team have made available for VoxxedDays, and it pulls data from there and uses a local cache to store things. So if you go offline for a little while, you still have a local copy of the data that you've already downloaded. So, as Matt mentioned before, Flutter offers something called platform channels. So you can get a lot done, as you're about to see, in Dart, sort of in Dart land. But sometimes you need to talk to the platform. There's no way around it. So local notifications, for example, is one of these. The APIs for those on Android are Java APIs. And on iOS, they're meant to be interacted with Objective-C or Swift code. And so with platform channels, you can put a single Dart interface on both of those. And it'll handle wiring up calls made into Dart into sort of Android land or iOS land on your behalf. And it'll marshal data across from the Dart isolate into the platform area, and it'll translate types for you as well. I don't know if anybody's ever used Unity in here, but they have a similar setup for doing things like this as well. All right. So the app, it pulls data from a number of locations. The Voxx.com sort of master REST API that maintains the list of upcoming events. Each individual conference, of course, has its own conference in a Box server. And so it'll, to pull schedules, it needs to know which one to go to for a particular event and pull data from it. It also has a local cache that it both reads from and writes to, and then has a cold boot JSON file. So if you install the app and then you go somewhere where you don't have network connectivity, it actually ships with some information about the conferences built in so that you can still open the app and look through it and it all will make sense. But that's a lot of data coming from a lot of sources. And so how does that sort of get managed? Real quick, is there anybody in here who's used Redux before? A few of you? Okay, a few JavaScript developers. This app takes advantage of a library called reblock, which is a combination of Redux and another pattern used by Dart called block, which is business logic components. It's a separate open source library, and it maintains app state in a single object. So everything that the app knows about the list of conferences and who's speaking and all that, that's maintained in a single object. And it uses Dart streams as a way of wiring up changes that happen to this object. So in keeping with the Redux pattern, there's a store that manages your app state for you. And this store accepts actions, which are how you mutate the state. And these actions sort of go into a stream, and they're acted on by various pieces of business logic. And at the end, after an action is completely processed, you get a new app state object. So the state of your app becomes this stream of state objects. And then the widgets can be wired up to represent those state objects. And I'll go into this piece by piece here. So an action, these are how you change your app state. So in a minute, you're going to see me dealing with an action called toggle favorite. So if I have a session that I want to remember as a favorite one, I might dispatch an action called toggle favorites. And it carries with it the data necessary to make that change. So to toggle a favorite, you might need to know which conference you're talking about and the ID of the talk. And so that action is a strongly typed class that carries that data. It will go into the dispatch stream and be acted on by middleware, reducers, and afterware, which again I'll talk more about in just a second. And an action can be canceled. If a piece of middleware logic looks at an action and says, this is not the right time for that, it can actually cancel the action and prevent it from being processed. So your app, you will be dispatching actions to a store, and the store exposes a way to do that. It's a dispatch function. Each action, when it goes into that function, ends up going into the sink of a stream in the very beginning. And the other end of that stream, after everything has been done processing, is a new app state based on that action. And the app state is changed by reducers. So reducers receive actions. They're wired into this dispatch stream. They can check the type of the action, decide whether or not they want to act on it or ignore it. And if they do act on it, they'll take the state of the app at that particular time, mutate it in an appropriate way for the action. So again, if it was toggling a favorite, maybe it might look at that conference ID and the talk ID and go, oh, I need to add this ID to my list of favorite actions. So I'll update the app state and I'll put another ID in there. Then it takes that action, or the resulting app state, and passes it on to the next reducer. So we can take a look at it and decide whether to act as well. Before the reducers get their chance, though, there's something called middleware. And reducers are pure functions. All they do is examine the action and produce a new state, whereas middleware are allowed to perform side effects. So maybe I have an action that just needs to kick off a network request. Middleware can do that. Might also interact with shared preferences or do some logging, things like that. Middleware can also dispatch their own actions. So if I have middleware to go start a network request, when that request completes and I have some new data, that might get dispatched as a new action to be reduced and added to the app state. Middleware can also cancel existing actions, as I mentioned before. And so after the reducers, there's another chance for side effects. These are called afterware. They're just like middleware, but they execute after the app state has already been updated. So if you needed to cache your app state to local storage, for example. So you got some data from the network, you updated the app state, and then you're like, I'd like to write this thing out as JSON and store it so I can get to it later. Afterware is a great place to do that. Okay. So going back to a slide that Matt had up earlier, this is a representation of this very simple app. In Flutter, the entire app, not only is the app a widget, but it's represented as a hierarchy of widgets. That widget has children, and they have children, and so on down. This is a very simple example, as is this one. In reality, a Flutter app can be hundreds and hundreds of widgets put together, each doing their own very particular job. And so you get this stream of app states managed by the store. You have a widget tree that's going to represent that to the user. And when you get an update, it's, you don't want to rebuild the entire tree. That would take a little while, even in Flutter. And so it'd be nice if you could just say, rebuild a few things. If you need to, change the app state in such a way that just one icon should be updated or a little piece of text change, it'd be nice to be able to rebuild just a portion of the tree. And to do that, Reblock offers the ViewModel subscriber. And this is a widget. As we said, pretty much everything in Flutter is a widget. And this one subscribes to that stream of app states. And so every time a new one is kicked out by the store, it'll get a little update. It takes its state object and converts it to a view model. So it filters that large state object down to just the information it needs. Then it takes that view model and builds widgets with it. And so you can see here we have a converter and a builder function to do that work. And so here, if you had those three widgets and they were just there was a little piece of the state that was just for them, you could have a view model subscriber that would convert that state into just the piece of data that they need. And then when they got a new view model, it would ditch the old widgets and rebuild just the new ones. All right, so let's look at some code.
We've talked about a bunch of foundational things. What we want to do now is actually do, for the next, say, 20 minutes or so, actually do some coding. We're not only going to show you the code for the app itself, but Andrew's going to potentially code a new feature.
Yeah, we're going to code something up. So this is the code base for the app. And let me give you a brief look at some things just before we start. So we have an iOS simulator running here with the app live. This is in debug mode, so it's running in a virtual machine. And so
we could have the Android emulator running here. We could have physical devices plugged in. We could actually have multiple devices plugged in if you want to do both iOS and Android at the same time. So again, we've tried to make this as flexible as possible in terms of what platform you want to work for or with both at the same time.
Yeah, if you're designing UI and you want to have the largest possible device and the smallest possible device running at the same time, that's actually quite handy, and you can totally do that. So this is my app state object. I mentioned before that the state of the app and everything it knows about the conferences is in one object. This is that object. You can see it's got a list of conferences. It has a list of speakers and schedules broken down by ID, as well as some other things. It also has session notifications where it stores the favorited sessions, as well as the ID for the local notification that will represent it. So that's that object. And let's take a look. This is a block. This is where you can see a middleware, some reducer and afterware. And so the middleware in this interface it's just a simple function. It receives an action as well as the current state. It can check the type of the action, decide whether it needs to do something in response. And for example, here with refresh speakers for conference, when this block receives that action, it automatically kicks off a network request to go update the speakers for a particular conference. And then when it's done, it can actually dispatch another action to say, hey, I'm done. Here are your speakers. Please add these to the app state. And then those are reduced down here in the reducer. And let's take a look at a widget here. So this is a talk item, which I'm going to show you in just a second. If we look at the schedule in the app, let's go over to Tuesday. This one doesn't have any Monday sessions that are finalized yet. That little row with the orange text and the name of the room that's in use, that's produced by one of these widgets. And it takes a schedule slot, a conference ID, and a list of speakers. And then it builds itself out of other widgets. So you can see some other things down here, gesture detector, padding, row. It's composing its UI out of other widgets. All right, and then let's take a look at conference detail. So this is, let me just squish everything here. So this is what you're looking at on the right, the conference details screen. And so this is building that scaffold that you see at the top. It's also building the navigation bar at the bottom. Let me go ahead and open this one. So you can see it has a scaffold, just like Matt's example. It has an app bar. It also has a drawer that can be opened and closed here. So you can pick a new conference and so on. And this is, of course, a widget as well. It's a stateful widget. So we have a widget up here that accepts a conference ID. And then its state object, the only piece of state it actually needs to track is right here. which is just a purely UI detail. It's just the state of the navigation bar at the bottom, which item you have selected. And so what I would like to do is to add a new item to that bottom navigation bar and see if we can get a new view in here of just the talks that have been favorited. So this is the schedule as it exists for Thessaloniki right now. And I'd like another screen that just shows me the ones that I've said, yes, that talk is important to me. So let me go ahead and do that. So my bottom navigation bar is getting built here. And of course, it is a widget as well. You can see it has an on-tap method that updates the navbar selection whenever somebody taps on it. And it also has this list of items down here. And so I'm just going to add another one. So I'll use a favorite icon here. Call this favorites. I save that. And so the magic of hot reload, I now have 4 items in my navigation bar, which is great. Let me go up here to where I'm building the body. And
so what we're seeing here is where you do the action when it's actually clicked on.
Exactly. So, and I can scroll down here real quick. The body of my scaffold, I'm sort of building on the fly, based on what the navigation bar selection is. And so let's say, so I've got conference info, schedule panel. Let's make a favorites panel, if I can spell. And that's going to start yelling at me because favorites panel doesn't exist. So let's go make one.
So one of the things that Andrew is doing here is you'll notice that we have templating built into our tooling here. All of this hot reload and whatnot is being handled by the plugin that we have for IntelliJ. And we have a whole bunch of additional features like, give us the small boilerplate for a stateful or a stateless widget. The widget detection works. So we've put a lot of effort into making sure that the experience and things like IntelliJ is a great. That's the simplest widget ever.
Sure. Yep. And so one other thing. So the favorites panel, it'll need to take a conference ID, so it can go get the favorites for that particular conference. Let me get that added. So I'll add final. And so this is a stateless widget, so all of its properties need to be immutable. So I'll add that, and then I'll need a constructor to accept it.
So here you see an example of you see an example of one of the shorthands that Dart gives for constructors. When you say this.conference ID, all it means is that somewhere a variable called conference ID exists in your class definition. Please go and just assign that value to it.
Yeah, so it's a little shortcut that handles the assignment for, and really threw me, coming from Java, when I first saw that in the constructor declaration, I was like, that's not right. I don't know what that's doing, but it can't be correct. All right, so let me hot reload that. And hopefully, there we go. So I have a new navbar selection now. I'm building the body based on that selection, and I have a very basic widget that's just saying hello. And so let's do something better. So this is going to need to pull some data out of the app state and get updated if that app state changes. And so the view model subscriber is how I do that. So let me replace this with one of those. And so the view model subscriber, the type of my app state objects is app state. And I'll make a little view model class here. Just like that.
So one of the things that we want to get across in this talk is the flow, the development feel for how you build things in Flutter. And what we're doing here is, adding a widget, making a change, seeing the result, going in, modifying it. And this is a typical flow for a developer on Flutter. And you go in and we are composing the UI, again, through code. But as you can see, certainly in my opinion, it's a very natural way of doing things. I'm not using XML, but I am doing it through the code, which gives us all everything you get with a modern programming language, such as conditionals, looping, and whatnot.
All right, yeah, so I have a view model subscriber now. And so it has a converter where it's going to convert the state into a favorites view model, and then it has a builder where it's going to build some widgets based on that view model to represent the data that it finds. And I've got the angry underline here because I haven't made the view model yet. So let me go ahead and do that. So this is just a class. And what kind of data am I going to need? So I need to show some conference sessions, which are called schedule slot in the API used by the REST service. So I'll need a list of those. Schedule slot, we'll call that slots, and I'll just start it off as an empty list.
So again, a view model in this scenario is just a nice way of representing the view when you construct your widgets from the more complex model underneath.
Exactly. It's a way of filtering down that app state into just the bits you need. And speaking of what I need, let me go look at the widget that I'm going to be using here. And so it takes a slot, a conference ID, speakers, alternate color I don't really care about right now, and of course is favorite. All of these are going to be favorites, so I don't really need to worry about that. And so I've got the slots, I've got the conference ID because my widget starts with it, and so I need the speakers. That's the other thing I need. So let me make a little, just do a map here of slot to a list of speakers, because you can have more than one. Call that speakers. Just start it off as an empty map. And always good to end your lines with a semicolon. And now I just need a constructor. So in my constructor, I'll take the app state that I get from the view model subscriber as one parameter. And I'll take the conference ID from the widget as another. And now I'm just going to sort of yank out the data that I need. So first, I have some helper methods in my state object to get some things. So I'll just say slots and all. And I'm going to grab, let's see, there's get favorite talks. There we go. And I already have the conference ID. So that's going to go into the state object and just pull the favorite talks for this conference. And then I need speakers. So let me go ahead and iterate over these. And I will do speakers for a given slot is, have another one of these handy getters, speakers for talk. And the talk ID is coming straight out of the slot, schedule slot object, like that. And so there's my view model. So I'm going into the state object and I'm grabbing the schedule slots that have been marked as a favorite. And I'm grabbing the speakers for each of those talks, and I'm just going to hold this in this view model, which then gets used down here for this builder. So go ahead and format this up. And if I hot reload this, I see hello again. So my view model subscriber is wired up. Now, let's actually display some stuff.
So again, here's another thing that you can do while you're writing Flutter. We typically go in and we can swap out widgets for other widgets as necessary because everything just takes the top level widget class. And what Andrew is using here is a handy widget called ListView. And what ListView does is it gives you an ability to show a potentially scrolling list of any type of widgets. And the important thing here is because we're controlling the rendering ourselves, if you come from like Android or iOS, typically like Android, for example, has recycler view where or recycler list
view.
Yeah, there we go. Where it needs to take care of what's on screen, what's off screen. In Flutter, we can do that for you automatically because we control the renderer. So if we were to build a list view with 1,000 widgets in it, for example, we will do the optimizations for this is on screen, needs to be instantiated. This is off screen. It potentially doesn't need to be instantiated.
Right.
You just need to create a list view and give it something, give it a list of something to show.
And so in this case, I'm going to give it a bunch of schedule slots. So let's see, my count, item count is going to be, and again, I have that view model in this function, so I can get the slots out of it. And so the length of that is my item count. Then I give it a little function that's a builder that's going to build each of the items in my list. And that gives me a build context and an index, so I know which one I'm dealing with. And I'll return that schedule slot item widget that you looked at just a second ago. And so this will take, actually let's do this. Let's real quick just get a reference to the slot out of the view model. There we go. And so this will take that slot, takes the conference ID, and then it also takes the list of speakers for that slot, like that. Oh, helps if I actually put the right property in.
And the dot in the right place.
And I overrode my bracket. There we go. All right, and add some semicolons here. And so if I save this, I should hot reload myself up, and there are the favorite talks for this conference. And so I should be able to go in here and say, you know what? I'm not as interested in this one anymore. No offense to stream processing with Hazelcast. If I come back, it's already been rebuilt. So the view model subscriber, it's subscribed to that stream of app state. So when I went to the details screen, even though it's another screen somewhere else in the app, I hit that button, it dispatches an action to the store. The store updates the app state and kicks out a new object into the stream, and my view model subscriber automatically rebuilds. So that's, and then of course I can go back into the schedule, head over to Tuesday. If I were to favorite this back, I should come back here, and now I've got 2 again.
Seems kind of awkward that you have to jump all the ways there to favorite, not a favorite.
All right, that's, oh. and when I'm debugging, the notifications just go off 10 seconds after you favorite something, so I don't have to wait a month to see if my code works. So you just saw a local notification, that's why. But that's a good point. So I'm not really changing anything with what I've written so far, right? I'm just pulling some data out of the store for the most part and displaying it. I can add something here to, say, unfavorite one of these. So let me update the widgets that I'm building. So I could put an icon button on these in a row and then do something when somebody taps on the button. So with Flutter, if you want 2 things in a row, you use a row, just like that. And let me add an icon button.
So what you're seeing here is, again, layout using a widget. We have row for horizontal. We have column for vertical. And we also have a stack where you can overlay widgets on top of one another. So we give the basic building blocks that you can easily compose rows and columns and stacks into UIs of pretty complex layouts.
Mm-hmm. Yeah, it's weird when I'm working on designing something in Flutter. It reminds me more of web development than mobile development in a lot of ways, because you get access to some very primitive widgets that just do one little thing or another instead of heavyweight views that I'm more familiar with coming from other places. Okay, so I've got an icon button, and so if I've got 2 things in a row, I'd like the icon button to take as little space as possible and sort of the rest of it to be the rest of the schedule item. So let me do that by wrapping this with an expanded, which will tell the row to give all the extra space to that schedule slot item. So if I save that, all right, I got a button. Mm-hmm. It does nothing. So let me add an on-pressed handler for it. And so this is just a little closure that'll get executed when the button is clicked. And so I want to unfavorite a talk when this button is clicked. So I'm going to dispatch a new action. And so the view model subscriber, in its builder, you also get the dispatcher from the store. So you can dispatch new things, which I will use here. And so I'll do a toggle favorite action, just like that. And that takes a conference ID, which I've already got, and the talk ID I can get directly from the view model, just like I was doing below. Oh, wait, actually, I've already got it, slot.talk.id. And so now if I save this and hot reload it, my buttons are now a nice color to say that they aren't disabled anymore, and I should be able to click one of these, and there it goes. So now when I'm clicking on that button, I'm dispatching a new action to the store. If that's processed, a new app state is kicked out, and my widgets get rebuilt automatically. All right, I think that is our code demo. Let me go back to our presentation here. And just a few things to wrap up, and then we'll take some questions, whatever anybody wants to ask. One of the nice things about Flutter is it's an open source project, completely. Not only is the SDK itself open source, but all of the tools are open source. Reblock is open source. This VoxxedDays app is open source. So if you look at this and you're thinking, that looks like fun, I wonder how I can get started contributing, any of those places are wonderful places to go. You can find things to work on there. Flutter.io is our website. You can find code labs at the Google developer site. Mm-hmm. You can find our samples on GitHub. And if you look at that, we have a cookbook of code snippets. And if you look at the very bottom line, that's the source for the app that you were just looking at. And so at this point, we're looking to transition this from a app that mostly we have been working on to something that the community is driving and updating. So if you'd like to get started with Flutter, that's a wonderful way to do so.
And the Gitter link there is a web-based IRC chat type system. We hang out there. The engineering, other engineering people on Flutter hang out there. So if you've got questions or whatnot, great place to go. Also, we pay a lot of attention to Stack Overflow, and we try to help out as best we can. So there's plenty of support, not only from us, but we have a really good community of people. The Flutter community is small, but it's growing rapidly. And it's always open to people joining, and is very supportive as people ramp up on Flutter. So I definitely recommend you make use of that.
All right, and there's our thank you slide. That has a link to TestFlight. If you'd like to see this app in action, you can get it right now in TestFlight. We'll have a beta build in the Play Store, hopefully in a matter of days. We just need to get a signed APK uploaded.
And if you can't wait, you can go and check it out on github.com. Type Flutter run on your command line.
Yeah, you can always,
you
always check it out.
Itself.
Yep. If you brought a cable, I can also just build it for your device right from my laptop. That works too. So who has a question? We tend to get a lot. Yes.
I have actually two questions.
Sure.
Can you say something about automated tests? It always sucks for native development. The second question is, what about device features that are available on iOS and not on Android? Is there a way to deal with that?
Sure. So let's start with the first one, automated testing. Let me go back into...
so the question was, what is Flutter's story, if any, for automated testing? And because we're smiling, clearly we have one for automated testing.
Yes, we do have one. I'm also smiling because the amount of tests that I've written for this app is shameful.
Shamefully good?
No.
Oh, right, okay.
So there are three types of tests that Flutter supports. There are unit tests, there are widget tests, and then there are full-on integration tests, what we call Flutter driver tests. And so unit tests are very straightforward. They just run in a very simple Dart test to make sure that some business logic is correct. Now that I'm thinking about this, isn't the best demonstration for it. Here was my model testing. And so this is one of those, if I open it up, just to give you an idea. I was checking that the model could serialize correctly to and from JSON. And so I have their test group, the normal things you would expect, test groups and things like that. So you have this at your disposal. You also have widget tests where you can test widgets that you've built to see, you can run sort of headless Flutter without a device, without an emulator even, and make sure that your widgets are rendering correctly and updating correctly. So you can have a widget and you can say if something is supposed to happen when you tap on a particular button, say, you can go in and say, find this widget by this ID, simulate a button tap on that, and then make sure that you can find some other widget that proves that the test ran correctly. So that's an option as well. And then there are full-on integration tests, which are typically run on device.
Yes, we have the driver tests. I can't express how nice the headless testing is. I use it all the time. I will build a widget. I will then write a test around it where I interact with a widget, and I will say, okay, now pump the display until it settles again, and then test its state. Or I can do pump the display for X number of milliseconds and test what's happening there. So you can interact with this, and you just need to have the basic Flutter SDK on your device. You don't need to have anything plugged in. It doesn't use any external device pieces. So you can pretty much write an entire testing framework and then run it on your CI or whatever without having to have any physical devices then. And then the full driver one is just icing on the cake, because then you can actually drive a physical a device itself.
For example, the last part of the testing question was testing platform features. For example, when I wanted to test that my local storage was actually storing things correctly, I can run test scripts specifically on a device as well. So I can make sure that they're working both on iOS and Android. That's also something you can do. And so the second part of your question was, how do you address things that are platform specific, device features and things like that? You can write a platform channels, we call them plugins. You can write a plugin that is specifically for iOS or specifically for Android if you choose to do so. And then you can, in your code, you can determine which platform you're currently running on and act appropriately. So that's certainly supported.
So you can, for example, say, if running on iOS, then implement this functionality, access this functionality in the hood. If running on Android, then show a different widget tree because we don't support it or whatnot. So you can. Any of the plugins we write, we try to make sure we give an abstraction that will work on both devices. Like storing key value pairs is different on both devices, but we've abstracted it away, accessing the camera, the notifications. But if there's a specific feature on device that is only on one device, you can't take that into account.
All right, who else? Oh, I see a hand up right back there in the light colored shirt. Sure. I mean, there are things that the best way to know the roadmap for Flutter is actually to go to GitHub and look at the Flutter/Flutter repo, and you can see the things that are currently being worked on.
We try to be as open as possible in terms of our roadmap. At the moment, we're barreling forward towards Flutter 1.0 release, which will be happening in the near future. We are then looking at what we do for that and beyond. Our focus at the moment are things like making sure we're getting the app size down.
Yep.
We're still tweaking we got some great performance, but we're still tweaking it to be better. We have a lot of first-party plugins, like I mentioned, camera and share prefs and other things. We are making sure that we have good coverage for the type of things you want to do, such as in-app payments, which you would always want to do in mobile as well.
There are a lot of things sort of being finalized and polished out. So Maps is being actively worked on and finalized. WebView, the same thing.
Yep.
Little details that need to be finished up before 1.0. I think people are working like crazy on.
And then beyond that, we're looking at what we do next year. There's things like we can talk from Dart to iOS and Android, Java, Objective-C. We've had a lot of asks for the community to be able to talk directly to like C++ native libraries. That's something we're looking at for the future. We don't have a definitive time frame for that yet, but we'll be working on it. And over the next 2 or 3 months, you'll see we'll be very open in terms of what's coming next.
Yes. Pretty much everything is done in the open. And like I said, if you ever have a question, you can go straight to the source that the engineers are pushing on a daily basis and just see what they're up to. So. All right. Who else had a question? I thought I saw another hand up earlier. Oh. Yeah. Sure.
Two questions, one small one. I noticed that the IDE puts a comma at the end of every widget when you insert it, even though there's no next widget. And I saw you do it as well.
Mm-hmm.
And the second question is, do you think there's any chance that we can ditch the MacBook and just compile on my Linux machine? Because now I have to buy, well, I already did. I especially bought the MacBook just to compile.
So the trailing comma?
Yeah, let's start with the first one. The trailing comma is sort of specific to Dart. It is a way, the Dart formatter will give you a nice little new line when you put a comma in, which is why you see me doing it so much. If I were to take this one out, Dart thinks that I want these all on one line and will format it accordingly. And so that's trailing commas, even for the last item in a list, or even if there's only one item in a list, are allowed. And they're just sort of a little indication for the formatter for how you'd like something.
And I mean, you can disable the formatter if you so desire, but like I'm a personal fan of just sticking with what like a reasonable representation is, and I fall into the trap of just putting the comma at the end just so things tend to lay out on new lines, but entirely optional.
Yeah. And for your second question regarding whether a MacBook is required for Flutter. So if you're building for Android, and Flutter works on Windows, Linux, Mac OS.
The Flutter SDK.
Yeah, the Flutter SDK. I should mention. You can build on all of those. You can test on all of those. If you're building for Android, you can use any of them. For iOS, though, to build an iOS app, though, you have to use Apple's tools, which are made for Mac OS. So you're not really seeing it here, but if I were to build this app, stop it and start it over real quick, you'll start seeing messages from Xcode appear in my little debug window, where it's using Xcode under the hood to actually build the IPA that's going on in this emulator. And so when you go to, for instance, when we've been in the process of releasing this for iOS, the code signing and things like that you would normally do in Xcode, you are still doing for these apps.
Mm-hmm. But if you want to install the Android SDK, IntelliJ, or Android Studio on Linux, works great, as it does on Windows.
I just was because you're a little bit closer to the fire, let's just say, that you might have heard that Apple is releasing something for other platforms, because now it's a bit of a hassle, of course. My normal development environment is Linux, and now I write my Flutter app in Linux, and then
And
Maybe you know about rumors or something that it's going to be released.
I'll be honest, I personally haven't heard any rumors to that nature. I will say that if that became possible to build Apple or iOS apps on other platforms, then because we're already using Apple's tools to construct these, I would think that it would be relatively straightforward for us to be able to hook into those as well.
Yeah. And I would love to take more questions, but we're getting the red screen. Our time is up. Thank you very much for listening to us.
Yeah. We will be here for much of the rest of the day.
Yes.
You'll find us down at the Google booth. So feel free to pop around and ask any of the questions you might have.
We love answering questions.